guys, my name is Praveen. Welcome to Calculus 101. Later on you'll be seeing my loyal companion Jacob, but we're here today because we're going to teach you how to do implicit differentiation. Implicit differentiation is basically where you have a long equation with x's and y's and you try to find dy dx, which is the slope. So there's four key steps in implicit differentiation. They are differentiate with respect to x, collect all dy dx's, factor out dy dx, and then ultimately solve for dy dx. And we're just going to jump right into a problem. So find dy dx, our problem is y cubed plus y squared minus 5y minus x squared equals negative 4. So the first step is differentiate with respect to x. So we have 3y squared dy dx, and I put the dy dx there because once again we're differentiating with respect to x, and we'll keep going. The y squared turns into a 2y dy dx once again because we're differentiating with respect to x, and then the minus 5y turns into minus 5 dy dx because it's in respect to x again. And at the negative x squared, it's going to turn into minus 2x. And the reason we didn't put a dy dx there is because it's an x and we're differentiating with respect to x. And on the other side of the equal sign, we have a negative 4. And when you take the derivative of any constant, we all know that it's going to be 0. So equal to 0. There we go. We've completed our first step, differentiated with respect to x. We're going to go to step 2 and collect all our dy dx's. So on the left side of the equation, everything looks good except we have this minus 2x. So what we're going to do is we're going to add 2x to the other side. So we have all dy dx's. So we're going to rewrite this equation. 3y squared dy dx plus 2y dy dx minus 5 dy dx equals positive 2x after adding it to the other side. Now we have dy dx, dy dx, dy dx, which is collecting all the dy dx's. Step 2, complete. Step 3, factor out dy dx's. So just like any basic factoring, we're going to factor out what's common, and in this case dy dx. So dy dx, we're going to pull that out. When we pull that out, we have a 3y squared left in the first term, a positive 2y in the second term, and a minus 5 in the third term. And don't forget to write equals 2x again because we don't want to only work with one side. So that looks good. We factored out our dy dx. Step 3 complete. And the easy part, solving for dy dx. We have dy dx times a polynomial. So to get dy dx by itself, it's as simple as dividing the whole thing by that polynomial. So we divide dy dx times 3y squared plus 2y minus 5 by that. So we divide by 3y squared plus 2y minus 5. We do the same on the other side because you got to do the same on both sides, which gets us to our grand answer of dy dx equals 2x, which was on the other side, divided by what we just divided over, 3y squared plus 2y minus 5. And that is our answer, and we solve for dy dx. There you go. There you have it. Implicit differentiation part 1.
Hey guys, I'm Jacob. I'm here to teach you a little bit more about the advanced part of implicit differentiation after my partner Praveen taught you about the basics. So let's jump into this problem right here. It says, find d squared y over dx squared at this point, negative 3, 4. If you didn't know, d squared y over dx squared is the second derivative of an equation. So it's asking for the second derivative of this equation, x squared plus y squared equals 25. And it looks like they gave you the first derivative. So to define the second derivative, you take the derivative of the first derivative, which in this case you'd have to use the quotient rule for. So the quotient rule is the denominator times the derivative of the numerator, which is negative 1, minus the numerator, which is negative x, times the derivative of the denominator, which in this case would be dy dx because you're differentiating y with respect to x. And then all of this divided by the denominator squared, which is y squared. This question is asking for a certain value for d squared y over dx squared. So you can use this point that they gave you up here, negative 3 comma 4, and then just plug it in using x equals negative 3 and y equals negative 4 into this massive equation right here. So you plug in your y's and keep everything else, and you plug in your x right here, which in this case would be a negative 3, so becoming a positive 3. And here you get negative x over y because you're plugging in dy dx, which they gave you up here in the first part of the instructions. So you simply move this into here. And then keep this all over 4 squared. If you just plug in your y values and your x values correctly, you should be able to simplify this question all the way down to negative 25 over 64, which is your final answer. After doing all this work and learning about the basics and the most advanced parts of implicit differentiation, I hope you know and understand what all of this means. Ready?
Yeah, say something.
Ready? Ready?
Yep.